Consider the reaction between hydrochloric acid and magnesium. Here the equation is provided. The first thing I'd like you to notice about the equation is that it involves what we call a single displacement reaction, where the hydrogen and magnesium have switched locations. The products of a metal and an acid are typically an ionic salt and hydrogen gas. Let's examine the oxidation states of the species involved. I can see that the hydrogen ion in the acid has been reduced. That would therefore make magnesium the reducing agent. If we consider the reverse reaction, we can see that the magnesium ion has been reduced, forming the magnesium solid. That would therefore make hydrogen the reducing agent in the reverse direction. Since the forward direction is favored, I can say that the magnesium must be a stronger reducing agent than hydrogen. What that essentially means, being a stronger reducing agent, is it's capable of forcing its electrons onto the hydrogen ion. The stronger the reducing agent, the greater its force in forcing its electrons on other species. Here's a list of other metals and their relative reducing strength, with magnesium being at the top and copper, and we'll eventually put silver in down below. All of these metals are capable of forcing their electrons onto hydrogen, with the exceptions of the ones below the dotted line. They're unable to force their electron onto hydrogen. Therefore, they are weaker reducing agents than hydrogen gas. Remember, the stronger the reducing agent, the greater its ability to force its electrons onto ions lower down in the series. Let's look at a couple of questions. Write both the complete ionic equations for aluminum reacting with sulfuric acid. First of all, the complete equation. So I simply have aluminum and sulfuric acid reacting. The aluminum and the hydrogen switch places in a single displacement reaction, producing an ionic salt and hydrogen gas. For the ionic equation, I focus on those species whose oxidation states have changed. So I'll provide those up here. We can see that the sulfate containing the sulfur and the oxygen, those don't change, so I can ignore them and just focus therefore on the aluminum and the hydrogen. So that is what we would call the ionic equation for what's written up above. Identify the metals that would react with hydrochloric acid. Of course, you would be provided with this information. Here we locate the hydrogen, and the metals that are above it would be capable of reacting. Hence, the zinc and the iron would be able to react, and the best answer then is B.